Wiley. I'm Research and Development Manager for Bipure Water. We're here to demonstrate our new technology, which we call Biperliminate. It's a new advanced oxidation process for the destruction of hard-to-destroy or refractory organic chemicals. The particular chemical we're going to demonstrate today is called methylene blue. Methylene blue is a dye. Specifically, it's a medical dye. And that means it's very safe. The technology involves an electrical system and a proprietary oxidant mixture, which is here in the graduated cylinder. We're going to add that right now. It's not instantaneous, it's somewhat gradual. We're going to start it off, timer. Okay. And the concentration of methylene blue in these two solutions started out at 10 parts per million. The one going through the system with the chemistry will be reduced in concentration and therefore color over time. It should take about 5 to 8 minutes. This is the 10 part per million methylene blue as a comparison to show you the difference. When the reaction proceeds, we're going to transfer some of it to the middle beaker so you can see the color difference a little bit more dramatically. This is an advanced oxidation process, different from more standard oxidation chemistry like hydrogen peroxide you might use on a wound. Advanced oxidations use free radical chemistry. Free radicals are almost free electrons on a molecule from the oxidant seeking to steal an electron to form a bond with something else. They're so strong in their oxidation capability, they will even oxidize water. But if there's something easier to oxidize than water, like one of the organic compounds, they will do that instead. You might have noticed that the color has already changed. Here we are at the 1 minute and 20 second mark. It's already purple. That's significant difference in the concentration of the dye, the methylene blue. Most of the color is already gone from the return stream. There's still some purple there. So again, we're targeting any refractory organic compound that's in the water, but we've added methylene blue to the tap water. In a traditional wastewater, there'll be many other compounds present, but fortunately, the chemistry is very non-specific. It'll destroy anything that's not water that's present in the water, and therefore will reduce the total organic carbon or the chemical oxygen demand. These are terms in the wastewater industry to represent how much stuff is in the water, things that we want to destroy. Now, methylene blue here is very safe. That's why we're doing this temporary setup. And it's used in medicine to determine the effectiveness of your kidneys. If you pee blue, your kidneys are working. However, this is representative of many dyes that are used in the textile industry, and a lot of those dyes are toxic. One of the other advantages about a strong oxidation like this, when it breaks up the molecule, the fragments, the broken fragments of the molecule are much more soluble and therefore less toxic. And therefore we're destroying the toxicity of the molecules at the same time as we're eliminating the color of the dye. By the way, the chemistry of a dye and the chemistry of, say, a pharmaceutical, like estrogen in the pill, is very similar. And so this process will destroy those as well. So if there's a mixture of, say, a colored dye and a pharmaceutical, it'll destroy both of them. Now, you've already noticed that the colors change to purple, but it's not as obvious that the intensity of the color, we call it the extinction coefficient of light, has been substantially reduced in the case of the reaction vessel. So we're going to transfer some of it to the beaker beside so you can see a little bit more dramatically the color difference. We're here at about the 4 minute mark. 4 minute, 8 seconds. So there's still a little purple color left, but it's quite faint compared to even the previous solution over here. And that's because it's passing through the system and reacting. So we're gonna transfer it back to complete the reaction. Notice the difference between the reacted color and the starting 10 part per million. This is down to a few parts per million. It's about 80% done by now. One of the initial markets that we're going to be targeting for this technology is India's textile industry. They have a huge waste problem, and it's very evident in the color of their wastewater. Another advantage of this technology is that it's completely scalable, since it's mostly a mixing tank and added chemicals and a small electrical system. This can be scaled up to any size. It's also got a huge advantage over conventional treatment with bacteria in that it'll destroy all of the refractory compounds, unlike the biology. Its also capital cost is many times smaller, and its footprint, the amount of land required, is a tiny fraction of conventional biological treatment. So even in industries and municipalities that are running out of capacity in their conventional systems, this technology is an excellent add-on. Remember, upfront costs are very small, at least 5 times smaller than a biological treatment plant. Its footprint is at least 20 times, maybe as much as 50 times smaller, so much less land is required. And of course, as I say, it's completely scalable, unlike biology, which is heavily dependent on the size for its effectiveness. And finally, it's largely temperature independent. Biology, of course, is very tricky as a function of temperature. Dramatic changes. If you get in cold temperatures, the biology literally shuts down. This reaction proceeds almost unaffected by temperature. We'll see if we transfer the stream now to the beaker and see about the color change. We're at the 7-minute mark. You can see we're more than 95% done. I would say if there's any residual dye, it's below the visible range. This is more than 99% complete. And notice there's still a little bit of dye in the reaction vessel on the left, but on the right, with once through the system, it's almost completely absent. I hope that this demonstration has been interesting to you, and we're happy to help with your wastewater problems. Thank you.